Yes, let me just share the screen one more time. So welcome everyone, day 2 of the Biomanufacturing Workshop by AC2 BioLink Regional Center. Today we have, this is our schedule for today. We start with a recap from Maggie Bryans, the recap from day 1, and this is the schedule. So Linnea, do you wanna get this kicking?
Yeah, I'm just going to go ahead and say, Maggie, you start. Oh, I do want to mention, because a lot of people are making comments. Yes, that's feeling that Ellen has. That's our youngest member in biotech at ACC. And anyway, Maggie, I'm just going to let you get started.
Thank you, Linnea and Purnima. I'm going to share my screen and just introduce myself and then go from there.
Yeah. Since I didn't bother to introduce yourself, since I know everybody knows you, I'll let you introduce yourself. How's that?
That's great. So hold on one second, should be coming up. There we are. Can everyone see that? And can you hear me okay?
Yep.
Okay, great. So I'm Maggie Bryans. I think I know many people that are here on this Zoom today, and I'm Principal Investigator of NBC2, which is a ATE regional centre for training biomanufacturing technicians, the Northeast Biomanufacturing Centre and Collaborative. I'm at Montgomery County Community College in the Philadelphia area. And this is my email if anybody would like to contact me, any questions about curriculum that I'm going to present or anything like that, please feel free to do so. So Linnea asked me to just come up with a few take homes from yesterday, and like her, I was really impressed with the quality of the speakers and the talks, and it was a wonderful day 1. And just to remind everybody, this is AC2's workshop 1, and there will be a workshop 2 in the spring where we'll talk about maybe mAb production, mammalian cell culture and processes, and some QC. So we'll do the other half, not the microbial, but the mammalian in the next one. And I'll show you some of that curriculum that we have in just a second. But so we started yesterday, and this is going to be brief, but we started yesterday with a fantastic overview of biomanufacturing from Jim DeClos, whom everybody knows, I think, from Solano College. And he just provided a great vial to vial description of the process. Vial meaning, frozen vial of cells to vial of drug products. So just a wonderful talk that encapsulated everything about the process, and included really great images of what a commercial facility looks like. Some of you may have not had a chance to visit one, and Jim showed great pictures of bioreactors, chromatography columns and skids and filtration units that our students often don't get to imagine or see until we take them to facility. And then he finished up his talk with a list of current and future trends for the industry, which is really useful for us, because we need to now go and investigate them so we keep our training and education of our students current, teaching them what they need, what's coming up next, for example. So a really nice talk by Jim. And then we had a quick break and we put him to work again, where he talked about proteins as products. What do we need to teach our students about protein products, the sophistication and the complexity of protein biotherapeutics, because knowing that will help them understand the challenges of the processes, the upstream and downstream process. We need to go through this 2-month campaign and come out with an active protein at the end. He talked a lot about glycosylation, which of course is very important, and had a great slide, which I think I might have to steal, on the capabilities of the different cell types as far as the glycosylation they perform on proteins. He finished up by giving us an example of TPA, which he's really familiar with, the amino acid sequence and structure of TPA, but how the manufacturers have made a more stable, better acting commercial TPA than the naturally occurring TPA by making changes at the gene level, which changed in one case, the glycosylation, and in another case, the amino acid change helped the protein be more active. So that's, I know my students always find that very fascinating, how we change the gene to make a better protein than is naturally occurring. So that was wonderful information, Jim. Thanks very much for that. And then we were treated to a talk by Joey Kirkpatrick, who's a fermentation specialist and a graduate of Langston Community College. Great training he got there, it seems. He works at the Michigan State University Bioeconomy Institute, and he knows those bioreactors inside out. And he gave us a great overview of pilot scale microbial upstream processing. And since he knows the process so well, he really went into detail about what can go wrong, the investigations that he's had to deal with, temperature probes that are malfunctioning, valves that have been left open, and how to investigate possible contamination. And I don't know about you, but me as an educator, I love to hear stories that have gone wrong in industry to relay back to the students, this is what possibly could go wrong. Because sometimes we teach GMP and biotherapeutic processing with batch records and SOPs, and the students get the idea, well, everything's wonderful, what could go wrong? We're following instructions. And things go wrong all the time. Often they're not catastrophic, but things in the process, things come up and it has to be dealt with through investigations. So thank you, Joey, for that. That was wonderful. And we've had a lot of take homes as educators from that talk. Then we heard from Isso Bayala, professor at Quincy College. And Isso is an expert in downstream processing and chromatography. And we'd asked him to give a lecture on basic chromatography. Someone wants to introduce downstream processing in the program. What should they be teaching? And he gave us that and more. In addition to going through all the process of chromatography and the different steps and the different types of chromatography, he taught us the importance of teaching our students to pour columns. And then importantly, to evaluate, just as Linnea just mentioned, to use that bolus of sodium chloride to introduce that to a newly poured column and look at the resulting chromatograph. And from that, calculate the number of theoretical plates, which is an indication of how well that column will function when it's used for chromatography. So he also reminded us to teach our students about the isoelectric point of proteins or protein products and how we can use that to our advantage in the buffer we decide to load them onto a column in, for example, and really enhance our ion exchange chromatography steps. So thank you for that, Isso. Great information, a great resource for faculty that want to introduce chromatography and higher, more sophisticated chromatography to the program. And then lastly, we had a tremendous treat from Dr. Dennis Gross. So he's a great partner of my program at Montgomery County, and he's the CEO of the Pennsylvania Drug Discovery Institute. Dennis's talks, as Linnea just said, that they're a gift. They're a gift that kind of keeps on giving because he gives us so much pertinent and great information that we can't almost absorb it all at once. We have to go back, and I do this with his talk, I have to go back to his presentation and unpack it a little bit because there's so much there. And it's all the stuff that we like to hear. So we're kind of like eating it up as he's talking. So he talked about, obviously COVID-19 vaccines. He talked about the front runners, what type of vaccines they are, how they're produced, the challenges with each, all the way from, development to the clinical trials and to distribution, which for the Pfizer one is a big challenge. We had an added bonus in that he presented actual slides from an Operation Warp Speed presentation. So I felt like we were lucky to get, the latest official data on, for example, distribution, who's getting the vaccine when. He had a great description of, the speed at which these vaccines have been developed and hopefully soon to be approved, and how that compares with a typical timeline for the development and testing and approval of vaccines. And that's good information for us as we try to explain that to some of the doubters, some of the people that are skeptical at the speed of which these COVID-19 vaccines have been developed. And we have several great graphics from Dennis to use at our disposal to show how that was possible. You know, the money that went into it, the amount of scientists and companies that were involved to get this to happen in the space of 18 months or so. So if you missed Dennis's talk yesterday, please, once Purnima puts it on, it's absolutely worthwhile. All the talks are to go back and review those presentations. They're absolutely wonderful. So that was some of my takeaways from yesterday. And Purnima asked me to talk a little bit about now online resources for biomanufacturing. So I'm going to present some slides on that, NBC2, but some other resources as well that you might already be available, but some might be new. So just a little bit about NBC2. I think most people know about NBC2 since this is a biomanufacturing group. I would hope so. We're a regional centre. We've been in existence since 2005. So we've been going for 15 years, and it was initially initiated by Dr. Sonia Wallman at Great Bay Community College, and she did a lot of the early curriculum development at Great Bay that I'm going to be talking about, her and her team up there that I'm going to be talking about for the microbial curriculum that we have. And then in 2009, it came to Montgomery County Community College, and that's when I became involved. So over that time, we really carried out many of the points that are in the mission of the ATE, developing curriculum for technicians, advanced curriculum for technicians, professional development of faculty and high school teachers, introducing biomanufacturing to middle school and high school students. So all the points that ATE really want you to include in your project, we were able to do in this regional centre. So today I'm going to talk about the online curriculum and teaching resources from NBC2 to teach biomanufacturing. And then some of the other resources I have are really professional development resources, I feel, for us, although they can be introduced to your students as well. So some of these ones from Nyberg and Nimble are more sort of a faculty oriented, so we can stay current and knowledgeable on the field. And these are just some of the resources and the sources of these I'm going to be talking about. But first I want to talk about NBC2. So this is where we house all of our curriculum and any information or keynote speakers we've had for any of our Bioman conferences, mini Bioman conferences over the period of funding. So this is a great resource for anybody who wants to introduce biomanufacturing or to develop a course. We have skill standards in order for you to start with, to develop curriculum, for example. And I'm going to just come out of that for just a second so I can just come to the actual website and walk you through it. So hopefully you'll see this in just a second. Are you seeing that yet? No, you're not seeing the website. I don't think. You might have to share the screen again.
Yes, I can see the website.
You can see the website. Is it up?
I can see it.
Yeah, we can see it.
Not up on mine, so on my other screen. Okay, great. So, so this is the NBC2 website at biomanufacturing.org, and this is where you'll find our curriculum. And we initially started with biomanufacturing units that would represent the 10 different technician jobs that make up a biomanufacturing facility workforce. So that's where these units initially came from: upstream processing, downstream processing, etc., quality assurance, quality control, microbial control, and so on. And each of these units have an associated textbook chapter, because in 2012, we developed an introduction to biomanufacturing textbook. And now all of these chapters are available to download freely online. But just to give you an idea of some of the curriculum you'll find in a unit, this is our upstream processing unit. and that might be a little bit small on your end, but I'm going to bring a few of them up so you can see. We have developed for AC3 monoclonal antibody production upstream processing using CHO-DP12 cells, growing these cells in a shake or spinner flask all the way up to a bioreactor. But for this conference, we really thought we'd focus on microbial, and this is some of the work that Sonia Wallman produced, and the production of GFP, which many of us use in E. coli. So for my program, I teach the E. coli production in the GFP production in my Introduction to Biotechnology in my Techniques course. So they learn about microbial production before we move on to mammalian protein production. So Sonia developed a lab manual, and this is just for upstream processing. No bioreactors required. This is, you can just produce this in an Erlenmeyer flask. And this just provides the SOPs and the batch record where you can follow the growth of the cells through measuring the optical density, for example. And then there's also, we have human serum albumin production in Pichia pastoris, also developed by Sonia and her team. And so those are the two microbial production systems we have to help people get started in introducing this into their program. So that's upstream processing. And just to give you a little bit on downstream processing, and this piggybacks onto what ISO was discussing yesterday, where we have, and we had a little bit of a conversation about ACTA versus Biorad. So we have information, standard operating procedures and user guides for the ACTA system for anybody who is acquiring a new ACTA, and it's kind of complicated once you get it. When we got ours back in 2013, it's a complicated system, but once you get to know it and use it, it's absolutely worthwhile. It's really efficient and effective at purifying proteins. So for example, this is an SOP for producing GFP from E. coli lysate using anion exchange on ACTA. So that's just an example of one of the SOPs that's available. And again, we have SOPs also for the Biorad Biologics LP purification system. So this was a precursor to the one that we were talking about yesterday, but many of us still have these units because they were very popular at the time. So we have some SOPs for that system as well. So in developing our curriculum, we've kind of focused on what an instructor might need to introduce this, introduce these processes. So giving detailed standard operating procedures, giving operational SOPs for the equipment, even if you don't have exactly the same equipment, you can change them up to suit your particular facility. We also have an IMAC affinity purification of GFP that Linnea was talking about yesterday, SOP as well. And this is actually using just gravity chromatography, I believe, in this one. So those are some GFP purification SOPs that are available. And then of course we have, the monoclonal antibody purification and also tissue plasminogen activator. That's what we purified before we moved over to the MAB purification. So Jim talked about this yesterday. He knows this protein very well. Batch records for producing TPA from CHO cells and purification of TPA on ACTA. So depending where you are in your biomanufacturing curriculum, these are SOPs that will be very useful for incorporating it into your program at several different levels. I wanted just to talk about a little bit about the instructors portal, and many of you are already signed up for the instructors portal. So again, one of the missions of NBC2 was to develop curriculum in such a way that faculty could adopt it and then mentor them in adopting it. And part of that mentoring was running workshops. And over the 15 years, we've run Bioman workshops and then mini Bioman workshops for the last 5 years, where we took just one particular area of biomanufacturing, for example, single-use biomanufacturing and upstream processing. And Izzo and Bruce at Quincy College, helped us with that, Mini Bioman. So we understood we could only teach 12 or so faculty in these workshops. So we took everything that we taught in those workshops and made it into a curriculum module. And you'll see that in our instructors portal. So we have 170 instructors that are already using the portal. And this is what you will find, some familiar faces there. And this is what you will find in the instructors portal. So the reason we kind of have this behind a sign-in is because we do have a biomanufacturing exam that we don't want to make freely available to students, obviously. So that's a multiple choice exam that covers the whole biomanufacturing soup to nuts process. And then we have the curriculum modules that I just mentioned that really came out of our conferences, our workshops. And so what we wanted to do with these modules is provide everything that you would have gotten material-wise if you'd come to the workshop, all the SOPs, the material and reagents lists for incorporating these experiments, and all the PowerPoints that give an overview to each of the experiments as we're teaching them. So hopefully you would find this information very useful to when you're adopting some of this curriculum and introducing into your program. Again, we had a great talk by Dennis here at this one as well, as you can see. So we also have our guest lectures as well, monoclonal antibody manufacturing from Pinar Sikalis over at GlaxoSmithKline, and then a talk from Dennis. So each of these modules look like this: SOPs, PowerPoints, materials list, anything you would need to incorporate into your program. And then going back one more time. This year, we introduced also a production manual for monoclonal antibodies. So really combining all the upstream and downstream processing and QC, including ELISA and HPLC testing for aggregates, we put together in a lab manual for producing monoclonal antibodies. And since we all moved virtual last March, and many of us were teaching biomanufacturing at the time, I gathered representative data from the last 5 years, and myself, Hetal Doshi, and Robin Zook put it together as biomanufacturing data for instructors to use in their teaching. So this was something you could use teaching virtually, since we provided, and I've already talked about this in Innovate Bio, so you might be familiar with this already, but just to briefly bring it up again, this is biomanufacturing data from our course that we teach, monoclonal antibody production, upstream processing. This particular data is all the upstream processing data. And so this can be used to teach manufacturing virtually. This is what you will see, or to prepare the students before they actually get into the lab. If we're teaching, for example, in a hybrid format. Also, we can use this data in our exams to assess the students. You can change some of the data points, maybe reduce the pH, ask the students what might have gone wrong with this run, that type of thing. So, so we've used this data in several different ways, and there's 4 of these data documents, if you like. This one is the testing, is the monoclonal antibody aggregate testing by HPLC. Again, using this to teach and also to assess students' knowledge after you have taught them it. So, so these are some of the curriculum resources we have for instructors in the instructors portal. So I think that's much of what I wanted to talk about for NBC2. And just in case my internet wouldn't allow me to do that actual website, I put some of this stuff in the presentation. So you have some of the material I've talked about. This is an example of a batch record, the batch record we use for making the anti-IL-8 mAb from CHO-DP12s. So sorry if this is making you dizzy as I go through fast. I did want to mention a little bit about our resources for high school teachers as well. So we talk about what is biomanufacturing. We have our Protein is Cash lectures. Protein is Cash is a workshop that Sonia Wallman initiated for high school teachers to introduce biomanufacturing at the high school level. So we do these workshops, and we've done them for about 15 years for high school teachers in the summer, and we call them Protein is Cash, from Ellen Doherty's famous sort of a quote. And this year we had a new Biotech in Your Backyard lab manual from Finger Lakes Community College as well. So if you're a high school teacher, you can check that out, as well as some other career resources for biomanufacturing for you to use. So I want to switch gears a little bit, and I'm happy to answer any questions about NBC2 resources, or feel free to email me about anything you find on the website that you would like more information on. But for now, I'm going to switch gears and just talk about other resources that we use, or maybe some of them might be new to you, but I have used in my courses, especially my introductory courses, NC BioNetwork e-learning materials. These are lab activities, and some of them the students get a certificate of completion at the end, so you can assign them for homework. There's different learning modules. There's a good one on HPLC. I used the screen fluorescent GFP one this semester, teaching my techniques course, because it really is a video that really explains cell lysis and clarification of the lysate by filtration, followed by downstream processing. So I assigned this as homework with a series of questions. So definitely look into NC BioNetwork if you're not using them yet for your courses. For biomanufacturing in particular, this was a course that was put together by the University of Maryland with NIMBLE funding, and I'll talk about NIMBLE in just a second. So University of Maryland with the industry partner Merck came up with this online course in biomanufacturing, and it's really good and it's very detailed. The charge is $50, so it's not cost prohibitory, and I'll show you some of the content of it. So this is just some of the content. So a lot of what Jim talked about yesterday here in the introduction, and then, you know, talk more about quality, and then all about upstream and all about downstream. So I found this very worthwhile, this course. And again, it's only $50. So I think this is great for us to prime us for teaching biomanufacturing, and you know, put in our mind what we should be teaching our students, because there was heavily involvement with Merck in producing this course. So that's another resource you can find online. And then we have Nyberg. So Nyberg is the National Institute for Bioprocessing Research and Training, and this comes out of Ireland. So about 10 years or more ago, the Irish government really put this pitch of and gave some tax incentives for biomanufacturers from across the world to actually manufacture their biotherapeutics in Ireland. And one of the big attractions was an educated and trained workforce. And to that end, they funded this National Institute for Bioprocessing Research and Training. And Nyberg is a state-of-the-art facility near Dublin in Ireland. And also they have this online academy. And so this is, all of the ones I'm showing here are free. So again, the Nyberg Online Academy. So if you go to the Nyberg site, they might ask you to make an account, which you don't have to pay anything. You just have to sign in with your email and password. And then there's all of these, some are 30 minutes, some are 50 minutes, but as you can see, glycan characterization, vaccine and immunity, inoculum and cell culture. So there are visuals, there's a voiceover explaining them, and there's also another one on upstream processing in bioreactors, which I had my students do as part of our course. So this is another really good resource, both for faculty and, since they're free, for students also. So I encourage you to check out Nyberg and their online academy. And then there's NIMBLE, the National Institute for Innovation in Manufacturing of Biopharmaceuticals. Most of us have heard about NIMBLE, and we're involved in some NIMBLE grants. So So they've been developing with 2-year schools, 4-year schools and industry education and training resources for the past 3 or 4 years. And there's 14 Nimble funded training programs that are available on their website. Most of them, unfortunately, are not free of charge, but they're still worth taking a look at because this material is very advanced and has a high level of industry input when it was developed. As you know, most or almost all Nimble funded projects have a strong industry involvement and industry partner. So this is some of what you'll find in Nimble site for education, training, and resources here. So, and then there's a whole slew of them if you scroll down. And this material is really advanced material, but great for our own edification, even if it might be a little bit advanced for students, our students at this stage. And then there's another one, and this is one that Jim's actually gone through, Jim Duclos gone through, the Principles of Biomanufacturing using Biotechnology to Manufacture Medicine. So this is an online course offered by MIT. It's a 6-week self-paced course for developing an integrated understanding of the creation of biopharmaceuticals. It costs $900 and some, so it's not free. But Jim can attest to its quality and content if you're interested. I went through and looked at some of the content, but just something else to consider if you have the time and the money to go through this, maybe over the Christmas break, maybe a Christmas present. So that's another online resource. And I just wanted to point out as well, I've talked about some websites and some, virtual training and videos and online processes, but I also wanted to talk about just staying current by subscribing to online newsletters. And I know some people cringe about online newsletters, but having these come into my inbox actually allows me to stay current, just going through the articles that are being that are written often by industry. There's some great white papers that come out of these newsletters as well. And these are some of the ones that are popping into my inbox every week. And I've actually used these and the material I found in these to develop some of the curriculum. When we were developing the SOP for aggregate detection by HPLC for monoclonal antibodies, there was a fantastic article came out that week on exactly how it's done in industry. So some of these, even though they can become a nuisance because they clog your inbox, I feel like there's great information in them, and it's hard to keep up. But when you can, it's good to read the articles that are coming your way and with these, these free newsletters. So I think I'll stop there and answer any questions you might have about any of these resources.
Yeah, so Maggie, I was wondering that $50 course from the University of Maryland, is that a whole semester? And is that per student cost?
Well, really, it's a self-paced. So it's a self-paced course. So basically, you do it when you can. It's units, so it's each person. I was actually, at my end, I was thinking of applying for a small college grant that would just cover the $50 for my 16 students. So that might be a possibility. So it's each login, or you could negotiate. I would like to negotiate a group fee for my 16 students, and that might be possible also, but I haven't yet looked into that, Rob.
I did it in a day.
Mm-hmm. Yeah, but you're Jim Duclos. You've already done MIT.
Well, the MIT one, if I can, is interesting because, as you may expect, there's a lot of math, and so you have to dust off your calculus. And my calculus was a little rusty, but okay. And where it's valuable going through the equations of power and shear force and diffusion is thinking about going from the small scale to the large scale. So you can model the process in a small scale and then move up. So I do recommend that one. It's good, but it is rigorous.
Mm-hmm. Okay. Thanks.
Thank
So
you so
Jim,
much, Maggie. And if anybody has any other questions, we do have our break coming up at 11:20. Please feel free to converse at that time as well. Our next session coming up now is bacterial production, comparing GFP, presenter is Iso Bayala. Thank you.
So I have, yeah, people feel free. I'm kind of curious, Maggie, and to the group, has anyone figured out a way to get students to help them read all these magazines? I mean, we've done some things where we've actually done that, where we assign students fine articles, but I was wondering if anybody else has done that, because I do agree it's really worthwhile to look at all these, but I find doing it all by myself is very problematic. And I'm curious if anyone else has had strategies for getting students to actually peruse these things.
That's a good idea, Linnea. You could even divvy it up between your students in your biomanufacturing course, you know, give them each one to take on and bring back to the class. I haven't done that yet, but I like that idea. I have just assigned articles because they're so industry relevant for homework and for reading to the students.
And I like your idea, because I love that idea. I like the idea of assigning a magazine to maybe a group of students and having them then be responsible maybe for once a month reporting out to the class or something. Well, I would be interested if anyone else has ideas. And I see Sharon does too. Thanks. Yes, thank you.
Can I start? Good morning, everybody. It's Saint Bonnie here.